Hi, Spring fans. Welcome to another installment of Spring Tips. You know, it wasn't too long ago, just a little while ago indeed, that it was release day for Java 2022. So happy Java 2022 release day to those who celebrate. I am a huge fan. You should have gotten the bits already because we're going to look at it today, obviously. So let's talk about it. First and foremost, friends, Java 22 is here. It has a lot of new features that build on the energy that we got from Java 21. Worthy upgrade in so many different ways. A lot of good, a lot of previews, and some things to be aware of, okay? Especially in the world of GraalVM native images. And we're going to talk about all those and more today. Let's get right into it. First things first, we need to install our software. I'm using SDKman, and you can too, by the way. It's here at sdkman.io, and its installation is pretty easy. Just pipe that bash straight into your terminal, right? Straight into your console, pipe that bash code. And with that, you'll have the SDKman CLI, and then you can say SDK install Java 22-Graal CE. Now, this is not just the OpenJDK version, it's the GraalVM Community Edition. There is actually a non-community edition, non-open source one. That's the commercial offering. It's free, by the way. I think it's actually free for every use case, but don't quote me on that. I could be wrong. But either way, it's free and you can use it as far as I know, but it's not the open source one. Okay, so for our purposes, just to keep things nice and simple, we'll do the open source one. So SDK install Java 22 Graal CE. You can see it's already installed. On my machine, I did SDK default Java 22 Graal CE. It is the default. And I went so far as to, for this program, for this example, I created a dear env file, right? A dear env file, right? So our dear env is a program that you can use to have activate .envrc files that are in whatever directories you navigate into. So in mine, I'm initializing SDKman, and then I'm saying use Java 22 within this directory. So even if for whatever reason in the rest of my operating system, I've got to work on Java 21, or I have to move on and use Java 30 in the far-flung future or whatever, for this program in this Git repository, which is on, of course, github.com, spring-tips/Java 22, that Git repository, if I clone it, in 10 years and I cd into this directory, this .envrc file will activate, and it'll install and then make default for this shell, the Java 22 Graal CE distribution. Convenient, right? Okay, SDKman also sets up your Java home and all that. You can make sure everything's working by doing, of course, Java --version or javac --version, and of course, prudently, the native image from GraalVM itself, --version. There we go. So we had all three of these things. They were released basically on the same day, albeit not in the same distribution. You can create a new project as usual by going to start.spring.io and just choose Java 22, and it'll set it up for Gradle and Maven. As always, though, there's this lag when I use Gradle, wherein the IDEs and the tools and all that stuff bark when I try to use Java 22. So for now, I'm just using Maven. And I'm not going to write a brand new project from here because there's a lot of stuff we had to configure to use Java 22 so early on, okay? That's why we're using Maven. It's because I know how to configure these things pretty readily so that it doesn't complain about all that stuff. I have the Git repository that's in the github.com Spring Tips repository, the Java 22 folder, and it in turn has the GraalVM native Maven plugin, which you get if you just choose GraalVM on start.spring.io, but I've enabled a bunch of preview features, okay? And a GraalVM feature, and we'll talk about that later. I'm enabling native access for everything. I'm enabling the foreign function interface support for GraalVM native images. I'm unlocking experimental features, and I'm passing in the enable preview argument, okay? That's great for GraalVM native images in particular. For tests, I want to enable preview language features as well. For the compiler, I want to enable preview features as well. I wish this existed here and there, but I said, yeah. And of course, down here for the Spring Boot plugin, when I do Maven Spring Boot :run and the like, I want to compile it and run it with enable preview plugged in as well. So now I have that across my compiler, my tests, my native image compiler, etc. Other than that, I'm also using Spring Boot 3.30 and later because that's going to have the best support for Java 22, right? Java 21 is, GA support in Spring Boot 3.2. Java 22 will be GA support in 3.3. Okay. All right. Now that said, I think the Spring Initializer will let you choose to create a project with 3.2.4, which should work with Java 22. So yeah, you could try that. But I'm using 3.3 because why not? Okay. So, and obviously, again, if you're in the far-flung future, hi, are we all still here? How's it going over there? And if you're watching in the far-flung future and you're on Java like 40, then yeah, please be my guest. Use that if you can. Let's dive into the demo. So first things first, friends, this is just a little housekeeping. It's a little meta, but we need to understand it just so we don't have to focus on it for the balance of our time looking at Java 22. In this project, I've created an interface called the Language Demonstration Runner, which has one method, run. You might say, hey, why not just use a runnable? And yeah, I would, but I don't want to have to deal with throwables, right? I don't want to deal with exceptions at all. I just prefer to be able to throw that or not declare it and then not worry about it and have the runtime capture, or in this case, just do nothing about it. At least I don't have to bedevil my code with all this extra exception handling, okay? So it's just an interface. All the beans that demonstrate a different feature today will use this interface just so that I can now, in a single place here, inject them, right? I'm creating a map of bean names to the instance of the bean, and I'm injecting it here, okay? And I'm going to go through each one, visiting each one, getting the bean demo, and then calling demo.run within a try catch. And I'm just going to rethrow a runtime exception. The framework will do something with it, right? I don't care. So that's all. This is just a little syntax, and the astute among you will maybe you'll spy some of the new features in Java 22. One of them already, but we'll come back to this, or the feature anyway, in a bit. Bye, Jay and I. This release sees the long-awaited release of Project Panama. This is one of those things that's been previewed and previewed and previewed so many times. I think it's behind virtual threads, but only just, right? It's been in trial for years and years and years. And it's one of those three features about which I've often spoken that I've just been so long waiting for. The GraalVM native images, that support landed in Spring in 2022. We've got virtual threads, which landed in Java 21 about 6.5 months ago. And of course, that is now supported in Spring Boot 3.2 as of 6 months ago, or 3 months ago. And of course, now we have Project Panama. Project Panama helps us to take advantage of, to work with, to repurpose and reuse the galaxy of C and C++ code. Now, when I say C and C++ code, actually, I'm not really talking about C and C++. I'm talking about anything that supports the ELF binary format. At least I think so, right? That it seems to me that that's what we're talking about here. There's new support in Java, which makes it easy for us to work with and to link against these ELF compatible binaries. ELF is a way of exporting symbols, and it was made a standard for Unix in the 90s. And lots of different languages can compile to C standard compiled sort of binaries. And I think that means ELF, basically, right? So Go and Rust and whatever, they have a much more complex language and syntax and different structures than C, but you can actually compile those programs in a sort of lowest common denominator way such that they can be invoked from other C programs. You can link against them from a C program, right? Which is very convenient. And I think the same is what's happening here as well. As long as it's been compiled down to ELF, then I think we can reuse it and invoke it from Java now in Project Panama. Historically, Java has been very insular, and it's not been easy for Java developers to repurpose native C or C++ code. It makes sense. Native operating system code would only serve to undermine Java's premise, the raison d'etre of write once, run anywhere. And it's always been a bit too taboo, but I don't see why it should be, To be fair, we've done all right, obviously, despite this, despite the absence of easy native code interop. There is, of course, JNI, which stands for joylessly navigating the inferno, or just noting infinity, or I'm not sure, Java native infinity. No, that couldn't possibly be it. It's not that. And anyway, it's in order to write and work with JNI, you need to write more new C and C++ code. In order to use JNI, you need to write more C and C++ code. The whole point, why would you have to write more C code to use it? The whole point is to get away from C. We don't want more C. The the idea that I have to write more C to use it from Java to repurpose existing C is horrifying and very much at odds with my idea of productivity, right? It's not great. It's a hemorrhoid-inducing experience, and I'm glad, frankly, it's behind us. The friction was so hard for so many sort of non-trivial use cases that it became more natural just to write it in Java. And that's actually kind of worked out, right? We have a huge ecosystem of Java-only solutions. Dollars to donuts, if you use a third-party library, you'll get something that works on your JVM. And when there are exceptions, and it does every now and then happen, people know about them, right? They become a big thing that the whole community is aware of. Like, for example, Netty. I think most of us who've done any kind of non-blocking or scalable work have had to deal with Netty. We understand that there's a native library we should be using when deploying on Linux, right? And also for DNS on Mac. I mean, there's just native things that we have to plug in. We have some things that require native code, and it's not pleasant. Project Panama is our way forward. It introduces an easy way to link to native code. There are 2 levels of support. You can, in a rather low-key way, manipulate memory and pass data back and forth into native code. I say back and forth, but really I probably should have said up and down, like from the top down to the native code. Project Panama supports down calls, where you call into native code from Java, and up calls, where you call from native code into Java. So you're in Java and you're calling native code functions, that's down calls. You're in the native code and you want to call something in Java, that's called an up call, okay? You can invoke functions, allocate and free memory, read and update fields and structures, and so on. So let's take a simple look at a simple example here, okay? This is our first example. This is the foreign function interface. I've just got a Spring Bean here. It implements our language demonstration runner, and it's injecting something called a symbol lookup. I have defined that bean. It's just a Lambda here, really. It's just a functional interface. Given a symbol name, return the memory segment for it, okay? So here, I've got a native linker. These both could work, and you might have a cascade. So what I've done is I've said, okay, look for the symbol using symbol lookup, right? The loader lookup right here, and try and find it. If that doesn't work, then try using this one, right? The native linker. So there's a cascade. If one fails, then try the other one. This arrangement does work. And you can see what I'm doing is actually just implementing symbol lookup in that one abstract method, okay? I inject that symbol lookup here, and when the program runs, I am going to look up printf. Why printf, you might ask? Well, it's a good question. I really spent a lot of time trying to find code that would work across Mac, Windows, and Linux, and be interesting and be observable, right? Like I could do network programming, but it's impossible. It's almost impossible to do something useful from C. And especially as verbose as what I'm doing here is, it's tedious. Most of the POSIX API definitions are for low-level things like file descriptors and memory and things like that. And so it's not really a cool demo, So I guess this is it. This works on all 3 platforms because everybody's got printf, surely. And what I'm doing here is I've got the symbol name, okay? And I'm looking up the symbol in my symbol lookup. I'm looking up the results from the symbol lookup. I get a memory segment. With that memory segment, I am doing a down call, okay? I'm saying, give me a actual thing with that memory segment, give me a function descriptor. And the function descriptor is, as I've described it here, of Java int and address, right? So printf returns an int and it takes a pointer, which is an address, okay? So I've described the shape of the function that I want, and I'm using the down call handle to down call a method handle that knows about this, right? Okay, so once I've got that method handle, I can now, within a scope here, with a try with resources, I'm actually creating an arena of memory. Okay, this is like malloc, basically. And in there, I'm going to allocate a string, taking a Java string, and it'll create a C string for me, which is actually just a memory segment. And then I'm going to get the method handle, and I'm going to invoke it, passing in the string. So I'm getting the method handle for printf, passing in the C string that we've created from our Java code. Okay, so we passed in a Java string, we got a C string. The C string is within this, try with resources. So don't share this. It belongs to this arena. And then I'm calling the function. Okay, so if we run this code on the JRE, we should see it starts up on the local machine. Let's go ahead and run it. All right, there we go. Hello manual FFI. You can see I printed it out. It's a long way around. Now you might be saying, well, this is tedious. I mean, I could do that, but it's going to be very painful to deal, like this is like a reflective API, right? To talk to the low level sort of C headers and all that, and to sort of get the symbols and all that. There is an easier way. There's a tool called JExtract, which was built with the Project Panama in mind. And basically it was developed in the context of it, but now it's made available as a separate thing. And you can get binaries of it and so on. So imagine you've got a C header for struct point2d, and you've got a function that returns a double given a struct of point2d. You can run JExtract against that header file, and it'll generate a package and a class called point2d in Java code. And you can call point2d allocate the arena, and then you can say point2d.x and .y, or you're actually setting the fields on the structure. And for this particular instance, this is the memory associated with that allocated point2d object, and you're setting the x and y fields on that structure, and then you're calling the function distance, and that function exists in the static imports for point h header, right, in the Java code. And that's all done automatically. So this is going above and beyond what we see here that's in the OpenJDK. You can use that, certainly. You'll get, it's behind the scenes, that code, if you looked at it, a lot of it is just doing what we're doing here in our Java code. Okay, now, what about in GraalVM native images? It doesn't work on my Mac. So in order for this to run, I had to do a couple things. First of all, I had to also provide a hint. You know how we have to provide those runtime hints for GraalVM during compilation for other things like reflection and serialization and JDK proxies and JNA proxies? Well, you have to do the same thing now for native images. And there's no JSON file. There's no Spring AOT component model method either. Right now, you have to write a feature class. So a feature class is a implementation of this type called or GraalVM native image hosted feature. And in order for me to have those types in the class path, you can see I had to explicitly add the Graal SDK and the Graal SVM dependencies to my build. Okay. Now they're just there so I can link against these types and compile, but of course they come with GraalVM itself. And this feature will get invoked assuming I tell GraalVM about it. And I'm doing that. You might remember back here in the pom.xml, you can see I'm passing in features equals, and then I'm passing the full path to this feature. And what this is doing is I'm programmatically registering for downcall this function descriptor, that very same one that I have here, static final function descriptor of Java int and address. It's package private, and that's just so that I can then reuse the same thing here during compilation. Okay, so I'm registering this function for downcall. Then at runtime, here comes Spring with this component, and it's going to do this Project Panama foreign function stuff, and it's going to look up the function. And that's going to work because we took the time during compilation to register that downcall. Okay, so far so good. So you can run that. I can't run it on my Mac. So what I did is I built a GitHub Actions project here, and it's going to download the JDK and install it, and it's going to run the native code. When I run the GitHub action, here's the native code, Maven PW native, Maven P for profile native, skip test, native compile, and then run the binary. And if you go to the GitHub Actions for this project, you can see the whole thing took about 6 minutes, 5 minutes and 45 seconds. And when it ran, there's the compilation and the installation of the JDK. And then we did the build. And when the application starts up, you can see hello manual FFI. So that does work. It compiled, like I said, in 5 minutes, 15 seconds there. And how long did this thing start up in? So 35 thousandths of a second, right? It's been running for 39 thousandths of a second in GraalVM. So you can see it's really fast, okay? It's great. You can write native programs that in turn invoke native code, all from the comfort and serenity of Java. If you wanted to use JExtract, by the way, I put it in the Git repository here. I put a little script called ffi_jextract.sh. And what this does is on Mac and Linux, the only two operating systems to which I have access, and even there, not very easily, I put the name of the operating system and the standard IO header, which you're going to need to be able to get access to printf, right? So 2 different tarballs and 2 different paths. And then assuming those are all in place, I download the JDK and I run JExtract, right? So I'm making the directory, getting the tarball, unzipping it, exporting the path, and then running JExtract to have it output all the header files it finds in the standard IO header file into a package called com example standard IO, which I would then be able to link to from my Java code. Bear in mind, this should probably go in another library, a jar, because the code by definition will be tied to Mac or Linux or Windows. So you might want to have some strategy where you can have 3 different jars in the class path, and you load one based on some runtime detection of which operating system you're on. I didn't do this by default because again, I don't want to check in all the resulting code and I don't want to set up a third-party jar. You can just try it yourself. And good luck with Windows. I'm sure it's possible. No idea. Haven't used Windows in earnest in 20, 24 years, 25 years. So, all right, good. Moving on. Another nice feature in Java 22 as a preview feature is implicit classes, right? And so basically, what is the minimum I can write to get a public static void main, right? We're normally used to something like public class demo application, and then we have a public static void main like that, right? Public static void main. There we go. That's my public class, and it has to be in a certain package, and so on. But why couldn't I just have a top-level function like in so many other languages, like C or Python or whatever? And why does that function have to be public? Who cares? It's the compiler. Why does it have to be static for that matter? It's the compiler. I can figure it out. Why does it even have to have arguments if I'm not going to use them, right? So that's what we're looking at now. It's just an implicit class and top-level functions. And if I rerun the program, again, okay, there you go. So you can see it's a preview feature, but it is really nice. Unfortunately, this doesn't quite work with Spring Boot yet, obviously, because where do you put the Spring application annotation? I don't know. We'll figure it out. Don't worry. But in the meantime, it's just a preview feature. Really convenient though, and it looks a lot nicer. And this will be a big win to help people find their way to the Java platform. Our next feature is not a huge feature, but it is a nice quality of life feature, namely statements before super. The idea here is you have some base class, let's say a secure certificate, which in turn has to make a call to a parent class because it has just one constructor, and that constructor requires some parameters. So the compiler can't just insert a call to the super no arguments constructor because we've explicitly opted out of that by having this constructor. So we have to satisfy that call. You'd have to do this, right? This is the only valid syntax that we've known up until now. And you can't do something before the super call and so on. So people end up doing like validations. Well, if you want to do validations with these bytes, for example, you might say private static void validate, right? And then just return the thing that you're expecting. So validate byte input, right? And you can say, okay, if in should equal null, throw new, or better, let's just log it out, invalid byte array. Okay, so now I want to do validation. I can't say var validated equals validate, right? I have to do something more direct. So that won't work. I can't have an expression or a statement. So I can do this instead, right? And you end up having these auxiliary methods that exist just so you can call the method from before the constructor and validate the parameters. And of course, I'm needlessly passing in the value I want to validate and then returning it because I have to have the result of this expression be not void so that I can do it within the call to super. And of course, it has to be static because even though this works, there's definitely no way to safely call or do anything with this, right? And so the language won't even let you do that. So this is all very tedious. You end up having all these very ugly static, private static auxiliary methods that are just there to do some validation before you make the call. So what if I could just move this here, right? Like that, and clean up. Well, the compiler, obviously the compiler in IntelliJ is not letting me do this, but this is now valid in a preview, right? So you can actually try it out here. If I go here, Maven Spring Boot run. So this is it. We may have errors in the compiler inside of IntelliJ, but it's actually valid syntax. So let's run the thing just from Maven, ignoring what my text editor is showing me. Let's just run the thing from Maven. So Spring Boot :run, and you see the program ran and we got invalid byte array. So in this case, I was able to put this before the super call. This is not supported in IntelliJ, obviously, but it will be soon enough. This is a preview feature, very convenient, very good for quality of life improvements. Our next feature is a huge quality of life improvement that's been long overdue. I think, in fact, more than 10 years overdue. Well, what do I mean by that? Back in Java 8, we introduced Lambdas into the language. And it's not true structural Lambdas like you get in a lot of other languages, but it's close enough. And the idea is that I can take single abstract method types, that's what we used to call them, or functional interfaces, SAMs, by the way, single abstract method types or functional interfaces, and then express them as Lambda. So row mapper of string row mapper equals new row mapper, blah, blah, blah. And so this is fine. It's an anonymous in a class, but really it's a class that exists just so I can call this method. So the syntax boils down to, well, just that method, doesn't it? So, okay, here we go, et voila. So now I've written this implementation as a Lambda. So it looks like an anonymous function or something. And when you invoke rowmapper.maprow, you're actually going to call whatever gets executed in between this. So hello world, right? So rowmapper.maprow, passing in the results set null and pass in -1, sure, and you'll see that gets invoked, okay? So there's hello world. Now, this is a functional type. It's a single abstract method type. But notice that in this case, the IDE is saying, hey, you're not using result set or row num, and good thing too, because one's null and one's nonsense, right? Well, I don't need to express these anymore now. That's the big feature. That's the big little feature. I can do anonymous parameter types, and that's very convenient because the compiler still knows that this is a row mapper. It's castable to a row mapper. I can also do var, by the way, if you want, but you have to cast, right? So that works as well. But either way, I have a method that takes a result set and an int. And if I need them, I can redefine them, right? Row num, like that. There you go. So you can redefine them if you need them, but I don't want them. And so I'm just going to make them, I'll make them unnamed variables. So this is very convenient. So we can actually see this in action here. I need the result set to get the data from the record, but I don't need anything else. I don't need that row num. So I just mark it as abstract or unnamed. Very convenient, very nice little quality of life change that will take the support that we already have in Lambdas just that much further. Well done. Gatherers are another huge feature that is, I think, long been awaited, right? It's one of those things where it just seems like a logical conclusion to some of the amazing groundwork done so many years ago in Java 8, okay? In 2014, for those who are not keeping track of every release of every time. You know, my friend Victor Klang, he's been on the podcast. I've talked about Scala and Akka, a lot of which he worked on in this very playlist, in this very YouTube channel. And his contributions to the Scala community in terms of the work around futures and all that kind of stuff is legendary. In fact, we talk on the internet about the legend of Klang, right? The guy is just amazing. And these days, he's a Java language architect at Oracle. And one of the things he's been working on is the new Gatherers API. The Stream API, which was introduced in Java 8, gives Java developers a chance, along with Lambdas, to greatly simplify and modernize their existing code, and to move in a functional programming-centric sort of direction. It models a set of transformations on a stream of values, but there are cracks in this abstraction. The Streams API has a number of very convenient operators that work for 99% of the scenarios, but when you find something for which a convenient operator does not yet exist, it can be frustrating because there's no easy way to sort of plug that crack. There have been countless proposals over the years, and indeed one of the most common things is people asking for new kinds of operators there. And it's very frustrating because it just feels wrong, right? So I'm glad in the intervening 10 years that they've sort of introduced this. It's finally arrived, albeit as a preview feature. Gatherers are a slightly lower level abstraction that gives you the ability to plug in all sorts of new operations on streams without having to materialize the stream as a collection at any point. Here is an example that I stole directly and unabashedly from Victor and the team working on this new feature. So this operator lives in this method. All of it does, right? And so this is reusable. It takes an initial supplier of the original state and then a function that will basically return the same state plus itself, basically, as a string. So what do I mean by that? Well, let's take a look at the stream of numbers, 1, 2, 9, okay? And then we're going to call the gather operation, passing in the gatherer implementation that we're building up here, right? And that gatherer implementation starts with an empty string. And then from there on down, as you encounter every number, we take the initial seed state and the number, and we concatenate the two. And then finally, we use concurrency to uppercase everything as well. So this is a built-in concurrent gatherer as well. And you can see that gather is composed nicely. There's a nice DSL here to plug in your own, and then to, in a chain, in a sequence with concurrency cared for as well, to sort of compose these things together. So let's go ahead and run the result. There we go. So we see 1, and then 1, 2, and 1, 2, 3, and then 1, 2, 3, 4, and 1, 2, 3, 4, 5. You get the idea. We're progressively adding more strings, more numbers to the string as we visit each successive number in the stream. How convenient. Another feature that's been sort of long in coming and very niche, but I'm glad to see it finally arrive, is a class parsing API. What do I mean by that? Well, if you have to ask, great, you shouldn't need to know about this stuff anyway. It's black magic and sorcery. It's absolutely way beyond most of our depths, but it's interesting nonetheless. There are a few libraries out there that cater to the very unique, perhaps even niche use case of having to both read and write .class files. Not Java source code. I mean the compiled byproduct from compilation, when you write and then compile to bytecode a source artifact, like a Java code page or .Kotlin code page or whatever. So why do we have this? Well, aren't there any existing things we can use to solve this use case? Surely, right? There's a number of them. There's ASM, that's the 800-pound gorilla, surely. There's CGlib, there's ByteBuddy. I mean, there's all sorts of good stuff built by amazing people. The problem, of course, is that this stuff, first of all, changes by definition only once the GA thing is out, right? So you are by definition waiting for these libraries to catch up with the current JDK before you can then update your code to depend on that library to depend on the new JDK. So there's now 2 steps between your ability to release a version of software and the new version coming out, right? That's not great. And second of all, they're competing. Well, this is one of the things where we found after 20 plus odd years of understanding the space, we've, I think, identified some common patterns. And even more to the point, even if we haven't, the Java team have, right? Remember, the JDK itself has 3 different, they use 3 different technologies for class file parsing, even within the JDK itself, right? So this is not just a unique thing that's interesting to the outside world. It's something that's useful to those providing the JDK proper itself. So it just seemed fitting that the functionality, the core SPI for that behavior live in the JDK. You can certainly still use and are encouraged to use some of these more powerful, higher level third-party libraries. But if you're on a newish JDK and you're interested in running a preview feature, you can try this out. And so here's an example of its usage. I have a resource, a Spring Framework resource. This is just a abstraction that deals with things that can provide bytes, okay? And we're pointing to a file in my local class path called default customer service.class. It's just a Java source code file that I've compiled to bytecode, and I capture that class file and checked it into my Git code, okay? And here, I'm going to use the Spring Framework resource abstraction to get the contents as a byte array. I'm storing that, and then when the program runs, I create a class file of those bytes, okay? So again, the bytes, I'm reading them from the class path. They could come from a file system, they could come from a network buffer, doesn't really matter. And then for each one of those, for the bytes that I read, I get a class model, and then if I iterate over the class model, I get class elements, right? So this is actually a thing that you can iterate over, right? It's iterable. There you go. So I have a number of different class elements. And here, I can switch through all of them. This is built by the JDK team using the latest and greatest language features. It makes sense that they make good use of data-oriented programming, the new smart switch expressions, pattern matching, things like that here in their example. So this is an example I basically borrowed from them. And here I'm visiting each element. I'm saying, are you a method? Okay, great. Say you found a method. Or are you a field? Great. You found a field. And so on. And I've got the empty default, but you can imagine doing something there. There's also similar support for writing. Good stuff. Let's go ahead and run this and see what we get. All right, I got a method for a constructor, and I got the ready method. Not bad. Now, of course, if you're compiling this into a GraalVM native image, you do need to do some work, but not for reflection. This is compiled code reflection, after all. It's not the same thing. You need to register the resource itself. The class file is going to be in the source main resources directory, but that's not going to be automatically picked up in a GraalVM native image. That's why I made the static and final, so I could then reference it from a static class called a hints, which I then import here. Nice. Now we have an application that does class file parsing even as a GraalVM native image. And then finally, another new feature in the Java language. This is a preview feature as well, just like class parsing. Are string templates or string interpolation. And if you've used any other language, like literally any, then you know that they have both multi-line strings and the ability to interpolate variables in the ambient sort of context. So in the string. So here I'm saying the name is colon, and then I want to evaluate the uppercase version of the name, which is defined here. Well, normally if I wanted to do that, I'd have to do, dot format or something like that. I'd have to use format codes and do all that kind of thing. Well, now the language, the compiler itself can build up a series of buffers for me. So now this language can do it. And notice that it's got this, if I'm honest, friends, I find this really ugly. Just disgusting, but it's a processor. the idea is that this is pluggable, right? And so this is imported implicitly into every Java compilation unit. It's a processor. There are other ones here like raw, and you can imagine writing your own, right? For JDBC, for things like that. You could actually write one that does named a parameter a resolution for JDBC, for example, or for a templating language or whatever, right? So it's a pluggable mechanism, but I think it just looks ugly. And the fact that it's just sort of sitting there, floating around in your code, I have to hope this is going to get fixed. There's got to be something more, I don't know, clean, to this. I mean, you can use raw, like we said. That'll just give you the effect of not getting in string interpolation. That'll just be a regular string. There's that for the one that we want. Okay, let's just run it. Let's see what happens. There you go. This is Josh, right? Very much so. All right. Clearly, there's a lot of new stuff here, a lot of which is gated behind this enable preview feature. That's okay. This isn't a long-term release or anything like that. I'm always just happy to have nice new features. Java 21 delivered and then delivered some more. So I'm not really feeling deprived, but I do think this is a very good release. There's a lot of cool stuff here, particularly if you're willing to use gated features. One of the big features that is GA that I think is endlessly interesting is that Project Panama, right? The foreign function interface. I cannot wait to see what people do here. There is a lot of interesting code out there that is written in the native world. And there's a lot of stuff that will land eventually here that will make things a lot easier for us. For example, Valhalla will give us the ability to use and not worry about auto-boxing of primitive types, right? I can just use fast primitive references without having to worry about that in my code. We also get things like SIMD, right? Specialized instruction set devices that can be used to really, really efficiently do matrix multiplication, particularly useful in the world of, games, graphics, and machine learning, two areas that I think we could all agree we should invest in right now. So that's coming in Project Panama as well. What we've just seen here is the foundation, and it leads to a lot of other stuff that'll be very useful. Just think about all the interesting things you can do that you might want to do on the server. Want to use image magic, for example? You could just shell out to the convert command, but there is a library. You could just link to it from your code. Now it's much faster. You don't have to marshal and unmarshal data to the command line invocation and all that. Just write a little wrapper around it in Java using Project Panama, and then deploy that. Make sure it works on Linux, and that's all you really have to worry about anyway. Most of us are deploying onto a Linux container, running today on commodity x86 Intel, maybe tomorrow on ARM. Either way, it's not like you have to make that C code work everywhere, just in the places that matter. And you can even wrap that behind a service, but that service in turn will have low latency. There's never been a better time to be a Java and Spring developer, my friends. These features, I talk about this all the time, but I sort of wonder out loud, what would we have needed to have, were we in the room in 2010 or whatever it was, to have persuaded people to build Kubernetes in Java? And I think about it a lot. It's a missed opportunity, right? We would have needed virtual threads, which we have now in GA Java 21. They would have needed easy foreign function interrupt, which we have now in Java 22, which we looked at today. And we would have needed small, singly focused, small form factor native binaries, which we have now in GraalVM. All of this is supported in Spring. It's all supported in Java. I think we can do some amazing things now. Really, really amazing things for which Java may not have been well suited in the past. My friends, I hope you got something out of this. As always, stay productive, and I'll see you next week.